Right. Thanks a lot for the opportunity of speaking here. That's a very nice opportunity, very good audience. And I'm Nils Hempelmann, talking on behalf of the Open Geospatial Consortium and what we are building up there in terms of climate resilience and the relations to C3S, the climate data source, etc. Just to give you a little bit of an idea what we're doing, these are a couple of selected projects where we are involved in, which are all connected to climate, but the OGC is actually doing much more than that. And so we are not only focusing on climate, that's actually more a new road that we are building up, but there's also a lot about defense, about health, about whatever you would like to have in terms of geospatial data management. And when we are talking about the technology readiness level, that's also a huge level, or the palette is very large. So from conceptual work, where we are currently in the climate domain, that's more conceptual for the moment, until up to interoperability experiments, or then also fully tested integrations. And then also the projects where we are involved in are small or very large. So kind of whatever it is necessary, it is possible that we are adapting to the OGC members or the organizations who are collaborating with us. And talking about the climate resilience community that we have built up within the last months and the last, well, 1.5 years, we were setting up quite a lot of ad hoc climate sessions where ECMWF had been also contributing, or ESA, the organizations which are here in the room as well. And if you're looking at this point, that we have member meetings, OGC internal member meetings, where then the 500, 600 organizations are gathering together, exchanging. So here, that was one of the rooms where we are talking about, but then also it was always dedicated to the UNFCCC sessions, and then we're presenting at the side events at the COP26. With that, you have also a clear idea, so we are not only focusing on Europe, but also beyond. So we have the colleagues from Canada, the US, Australia, Japan, etc. So if you would like to exchange with them, you are very welcome to do so. And brand new, that's actually today the official announcement. We have a call for participation in the climate resilience pilot. So if you are aware of a technical challenge that you would like to address and that you have a good idea how to do it, submit a proposal, and then you can participate in the upcoming resilience pilot. What we are also having is a domain working group on climate, and here comes already the main ideas of OGC, where we are talking about the so-called FAIR principles. And FAIR principles stands for findable, accessible, interoperable, and reusable. And that's very much known in terms of data. Well, yesterday and in the morning we have been talking about data and how to access this, how to find them, and then technically how to organize it. Then here OGC APIs are helping out. But then if you are talking about climate resilience information systems, so integrated technologies, then also we are proposing or thinking about that the entire backend, the entire things should be in that way organized and designed that the compartments are interoperable as well, findable, accessible, reusable as well. We have a domain working group on that, and to exchange it, and then always with the idea of giving the recommendations to the United Nations, to the UNFCCC, the subsidiary bodies there. And if you would like to have more insight of that, then the next member meeting will be in Singapore, the 5th of October, where we're actually selecting the chairs for this domain working group. ECMWF is nominated for that, so here you'll see the very strong connections between OGC and ECMWF. If you're now going into the details and what actually is C3S, the Climate Resilience Information System, if you talk that in general, we had yesterday from Paul the idea of the engine of a car with many compartments, and then the challenge is always we have the huge massive amount of data and how to shrink it down to usable information, deliver that to a user which is probably not technically and not skilled with programming knowledge. And so that's the challenge, and that's the way what we need to organize in the technical data infrastructures. And on the side of technical compartments, and here we are with the picture of the car. So here are the different compartments which are building up the engine, or this is the engine, the gears, the wheels, the windshield, the seat, the light, the brakes, etc. So all the different compartments. And we are proposing that these blocks, or so-called climate building blocks, are organized in that way that they are fully interoperable. So once a block is there, you can deploy it in wherever you want to have that. And then if you see the different sources of data that we had been listening to some of them in the morning and yesterday, some of the data are very well organized, others are not. So if they are very heterogeneous, if they have containing errors, etc., then the infrastructure needs to be clever enough of handling that then in the way. And going further, and also that's one of the ideas, one of the things that we have already in place, which are fully compliant to OGC standards, which are then also interoperable, and some of them are already implemented, as far as I know it, in the right way, so in the C3S. So the RUX is dedicated for subsetting, polygon subsetting, and then we have deployment mechanisms which are organized in a way so that the compartments are being deployable in a good way. And then others are, for example, implemented in the services from Canada, or in the services from Australia, and here we can exchange that in an international way. And if we are moving forward into that direction, then in a kind of ideal world, we can exchange all the algorithms that we have in an international way. Here comes the picture of the Ferrari again, from yesterday. That would be then now the extended version. Imagine you have multiple different car types, and then you can take whatever compartment you want and exchange that and build up your own kind of car in the way, in the way you need it. And take the part of an engine from a Ferrari, take the wheel from a Mercedes, take the windshield from WBR, etc. And then everything is fitting together. That will be then wonderful. And in the digital world, we are actually closer to that, because we can talk about standards, and we can have transition or translation mechanisms that makes that possible. And another thing that we set it up are templates of organizing actually this building blocks. So if you would like to have an algorithm wrapped up in an interoperable way in an OGC compliant standard, and then this is a template that we organized, and then just with a couple of commands on a terminal, that you will have the skeleton fully compliant and fully sticking to the OGC standards, including the deployment mechanisms. So it's a utility to lower the barriers so that scientific people can kind of ingest in a better way their algorithms into the climate resilience information systems, into C3S or wherever you would like to have it. And one of the real projects that we are currently being involved in, this is the climate intelligence, the CLINT project, and multiple colleagues of the CLINT project are already also here in the room, where we are actually organizing that in that way. So we have the scientific community coming up with clever algorithms, and then they're being wrapped up in the OGC APIs, and well, for not going into the details, and that's then the way of interacting and bringing and having good communications in between of the clients and the cloud and the server structures, with the idea of implementing that then into the C3S, into the climate data store, or wherever you would like to have it. So if you're fully complying to the OGC standards, it's also possible to deploy that in Wikio, for example. We have a talk later, or into the Canadian system, Australian system, or wherever that algorithms make sense. And An example, what we just wrapped up, which is very nice and very promising, is a Copernicus ready prototype that we're calling it that way. It's a process that is filling missing values. And here in the middle here you have a data set with quite a lot of missing values. And and then on the other side there is an and then you have a ground truth data set where you can train your algorithm, your artificial intelligence or algorithms, and then the result. And that's fully compliant, that's fully wrapped up as OGC standard and being deployable then into the systems, into C3S or Wiki or wherever you would like to have that. Another one is more complex, so you can also kind of chain that and having full data pipelines with very complex steps in between. That we have already organized the first step, and then the next one will come up in the upcoming months, including the mechanisms how to chain the processing services. And that's just an idea of what we are promising or what we are currently working on that. And then with the climate pilot, we can continue also with the same focus areas. And here is guidelines. And so if you would like to contribute, but you are not a high-level, sophisticated back-end programmer, and if you can write good text, or if you're a good graphic designer, you're more than welcome to contribute as well. And with that, thank you for your attention, and I will be around for questions.
Thank you very much.
Thanks a lot.
I just noticed someone writing code in the room on a laptop while listening to the speech. I'm very impressed. So is there a quick question for Nils? No question. It means it was very... Oh, sorry. Let's wait for the mic.
Okay, thanks. Alberto Trocoli again, Inside Climate Service. Just wondering, when you applied machine learning on the map, a reconstruction map, what kind of approach are you using? And did you apply to more complex situations? Because that looked more like a patching of two maps together and not real reconstruction. Thanks.
Nils. Exactly. Well, you are hitting the nail directly on the top. So that's what we are exploring for the moment. How much machine learning can we push actually into the cloud? For the moment, the machine learning modules are being trained manually, so that's still in the hands of the scientists. And we are also kind of having regional test sites where we're applying that. But the machine learning that I showed with the algorithms of filling values, here this is being developed by the colleagues in the German Climate Computing Center, and they're exploring currently with different data sources. So including also radar data, for example, and then exploring how good the mechanism is working. And then maybe in the future, you can help out if you want, is the idea that then the system or the technology, the cloud, is even kind of training and the initial data, the initial training model.
Thank you very much, Nils.
Okay.